In this video, we're going to cover naming alkenes. In our first example here, we have an alkene, so our suffix is going to be -ene. An alkene is a suffix-changing functional group, so we have to include both carbons of the alkene in our parent chain. That means that our parent chain is going to go down this way. Also, because the alkene is a suffix-changing functional group, we need to number to give the alkene the lowest possible number. So we want to start from the right to give the alkene a number 1. If we start from the left, it will get a 1, 2, 3, 4. So we're going to number from the right. Here we have an ethyl group at position 2. So if we put this together, we have 2 ethyl, pent, 1 ene. In our second example, we have 2 alkenes. Our parent chain then must contain both of them. So this will be our parent chain. If we number from the left, we have an alkene at 1. If we number from the right, we have an alkene at 1. So let's use this methyl group here as our tiebreaker. That means we're going to number to give the methyl group the lowest possible number. So we want to number from the left, 1, 2, versus the right, which would put the methyl group at 1, 2, 3. That gives us 2 methyl. We have 2 alkenes, so this is going to be a diene. That means we have a buta 1, 3 diene. The di indicates 2 double bonds. We use the 1 and the 3 to indicate where those double bonds are. And for some reason, they make us add this A whenever we add a di, a tri, or a tetra. In our third example, we have a cyclohexadiene. As we number, remember that both numbers 1 and 2 have to be on one of our alkenes. So this gives us a cyclo, because it's cyclic, hexa 1, 4 diene. Again, we have to add that A in there, so it's a hexadiene. The di again indicating that we have 1, 2 double bonds. In our last example here, we have a cyclopentene for our parent chain. And again, numbers 1 and 2 have to happen on the alkene. We also have a substituent here and here. So we have 2 methyl groups. And so when we're deciding where to put the 1, we have to put the 1 where the substituent is. So numbering around the ring, then this is the 1, and then we have another substituent on 5. That makes this a 1, 5 dimethyl cyclopentene. In this case, we didn't have to indicate where the alkene was because it's assumed that if we did it correctly, the alkene is at position 1. When you have disubstituted alkenes, you can name them using cis or trans. What I mean by disubstituted is that we have 2 groups on the alkene. And very specifically, we have to have those 2 groups on different carbons. So these are commonly referred to as 1,2 disubstituted alkenes. A cis alkene is shown here on the left. In a cis alkene, we have a hydrogen on each of the carbons of the alkene, and you'll notice that those hydrogens are on the same side of the alkene. The 2 substituents, the 2 ethyl groups, are also on the same side. And so this is where we have a cis alkene. In the trans alkene, the hydrogens are on opposite sides. In this case, so are the ethyl groups. So this is a trans alkene where the groups are on opposite sides. Again, 1 hydrogen has to be attached to each of these carbons in all of these examples. If you have a situation where you have 2 hydrogens attached to 1 carbon, like this, we can't name this molecule using cis or trans. There are other molecules that cannot be named cis or trans, and that's this example shown here. In this case, we don't have any hydrogens attached to the alkene. We have a methyl group here and a methyl group here, but those aren't hydrogens. This molecule cannot be named using cis or trans. We're going to learn how to name this using the EZ system in a different lecture. In this first example, first let's identify our parent chain. Here it is coming through here. And attached to this parent chain, we have a methyl group here and a methyl group here. When we number our chain, remember we need to number to give our alkene the lowest possible number. If we number from the left, 1, 2, 3, 4, that alkene gets a 4. So we want to number from the right, 1, 2, 3. So that gives us a 2,5 dimethyl hept 3-ene. The 3 indicates where the alkene starts. We also need to add the cis-trans designation, so let's draw in the hydrogens to help make that clearer. So now we can see that the hydrogens there are on opposite sides of each other, so that is going to give us a trans designation. In our second example here, again, we need to identify the parent chain first. Both of the alkenes must be in that parent chain. So this is going to be our parent chain. That means that over here is a propyl group. We need to number to give the first alkene the lowest possible number, so we're going to number from the left to put it at a 1. This is going to give us a 3-propyl hexa 1,4 diene. We also have to add our cis-trans designation for the alkene at carbon 4 here. So let's draw on those hydrogens. And you can see that they're on the same side. So this is going to be a cis alkene. We didn't have to add a cis-trans designation for the alkene at position 1 because it has 2 hydrogens connected to that first carbon. So it wouldn't be appropriate to use cis-trans here. This concludes nomenclature of alkenes. In the next video, we're going to look at nomenclature of alkynes, and we're also going to see what happens when we have an alkene and an alkyne in the same molecule.